Hello and welcome back to Compiler Programming. Let's start today's videos with a bit of cleanup and in particular implementing this command that we have here in the test that says that we should allow implicit conversion of last statement in the function body to void if the type of said function is explicitly specified as void. So this is kind of an interesting thing, and also the point where a lot of the times when you want to make things nice for the user, you end up with a bit of a messy logic because not that we have it at the moment, but there could be an explicit return in a function. And I think that if the return is explicit, then you do expect things to match, but if it is not explicit, then it would be awkward if you like forced to put another semicolon or do some other things, weird things, and just I think this should be allowed. Like this is just a nicer experience in general. So let's make that work, and we're just gonna remove this return type and try to run the test and see what fails and what we need to do. Apparently, exactly nothing fails. And this is a bit interesting. It's because I didn't save the file. So let's rerun that. Okay, yeah. So now we see a failure. It is inside of the function. So let's go, what's the line? 256, that's fine. 256, good. So we have an assertion failure over here, which makes sense. It says basically if we already have a return descriptor, whatever we are trying to return should match that descriptor, which kind of makes sense. And in the case of parsing right now, we always have a descriptor, which also something we might want to fix. Okay, but I think this function needs to have an extra parameter, and I will say that this is going to be an enum. So let's put it in the function.h, and it is going to be function. Let's do it in function return. So somewhere here, say type def enum, and this is going to be function return type. And what I want to say here is there's going to be function return type implicit and explicit. And implicit will make it the default one. I think that's perfectly fine. And this is what we're going to pass to this function over here. Say this is the return type. And this is also what we're going to pass to the function here. Okay, so here we say return type. We also probably need to fix this thing here, and this stuff will be an explicit return. So we say function return type explicit, right? Okay, let's try to build and see where we're missing. Yeah, so the only place where we are actually missing is in our lazy function definition. So here it will also be explicit. Let's reformat things a bit and say function return type explicit. In here it actually doesn't really matter because this is the first time we are doing it. It only matters in subsequent, and so it means that here we actually need to change the logic, and we say function return. I think it needs to have a builder, needs to have a result, and now it will say that it will be an implicit return type. Okay, that builds, but if we run the test, we still have a failure, of course, because we propagated that value, but nothing actually changed in the code. So what do I plan to change in the code? And the answer is very straightforward. And here we say basically that if a function returns, and if a function returns, what is it? This is a value. So we say if it's descriptor type is descriptor type void, and if return type is function return type implicit, then we just return. That's it, return. Otherwise, we assert there at the same time. So here, basically, we're just allowing to have an implicit return in case the return type is actually void. So this should take care of the stuff if I haven't messed up anything. Okay, it doesn't fully, I guess, because here we should actually be checking not to return, but this thing. So yeah. Okay, let's see. How's that? And it's great. Great. So we can even commit that right away, and we say that allow. Actually, let me also remove this comment here because I forgot to do that. So get that. Okay. Allow to have an implicit return of a value to in a void function. Okay, that seems good. This just was a bit of a warm-up, but I kind of like how it turns out. Okay, and the next thing is also somewhere over here. Guess where we have another fix me, which I want to look at, which is about descriptor S32. Where are you? I think it's in the force lazy function definition, force value. Yeah. So it is this stuff that is pretty interesting. So just to remind, if you missed it when you watched the last video or you haven't watched it at all, the problem that is happening here is that when you write number 42, that number doesn't really have a type, and different languages do it very differently. In C, I believe it is assumed to be a 32-bit value and even the signed 32-bit value. And then if you want it unsigned, then you say explicitly that it's unsigned by adding this U at the end. And if you want it to be 64 bits, then depending on the system, you have to add 1 or even 2 L. So it stands for long, long. I think this is pretty terrible. And I think that any modern programming language should just allow for implicit conversion of immediate into anything that can fit that immediate. So obviously, if I do something like this stuff, then we shouldn't allow it to be turned into I don't know, 32-bit integer or something. So yeah, that is the thing that I want to do today. And let's see how long it takes, and maybe we can do other stuff as well. But we need to do something about that. And I guess the interesting point is to decide where in the system you want to make that type concrete, like at what point that happens, because we can make it happen during the instruction emission. So we could, for example, have just a single operand type here and say that it's going to be operand type immediate. And then just before we emit the instruction, we try to find an instruction that has this particular size available. But that is going to work poorly with moves, I think. So at least in there, we'll have to do special casing as we do now to deal with immediate 64s. So another option would be to have to store immediates always in 64, but have a special descriptor type that says that it is doesn't have a concrete size. And it might, for example, have minimum size, but it not necessarily has a concrete size. So I'm not sure which option we're gonna go with. In general, descriptor integer already doesn't really say, so the byte size is a separate thing, and maybe that is enough for what we're trying to do. I'm not exactly sure. Another option for this, another solution for this problem would be to have to kind of make this immediate as small as possible, and then just let the rest of the system take care of it with standard means, which might be actually preferable. Yeah, let's do that, and then see how it goes. So the idea there is, okay, we have 42, right? And we know that 42 fits into a byte. So this will be the type of this value. And we can even say that the value is going to be, I don't know, always signed by default. So if we have 128, we will put it into already a 32-bit value or 16-bit value actually. And yeah, I think I like that rule. That would be not terrible to implement, and also would already help with the problem. Obviously, don't think we have right now implicit conversions between numbers of different sizes, so we don't automatically do that, but that makes sense. So let's do that that way. And all that is that we have this value from, so there is value from 64, 32, and so on. And instead of that, I basically want to do similar to EMM auto. I want to have a value from integer. Value from signed immediate. we get this value, and we say that, yeah, if it fits into S8, then we say value from S8, and if it fits into S32, we say value from S32, and finally we say value from S64. So we are missing actually value from S16 because right now we don't even have instruction to deal with it. So for now I'll do fix me add value from S16. But this is a sort of a separate story about the encoding. From value to operand. Yeah, this needs to return value star. Okay, and now we can try to use this thing here. Okay, let's see what that will turn up. I think we'll still have kind of an issue because right now we would have a smaller value and a bigger value, but that is definitely something that we need to fix. So let's do just that. Okay. It looks like we have to go back to the function we just edited, which is good because we know what there is there. Okay, that function is here and it fails at line 262. So as expected, it fails over here. And I think this is something that would eventually happen, and just now is a good time as any to start implementing this. So we want to have a function that would basically check if we can move this implicitly from one, or cast from one type to another type. So it will be similar to same type, and let's say that same type or just a second, same type or implicit cast. And let's go to here. There is our same type. We have bool, same type or implicit cast, the same deal as here. Okay. Obviously, we don't have the implementation of this function, so let's do that. Where is our same type? That is it. And we say, actually, this is probably not very inline. It will be something more complicated. Okay, so we say if same type of A and B, we just return true, right? So that's an easy case. And then the hard case if that is not happening. So what are the implicit conversions we need to allow? Well, let's start with the one that we have, and we say that if descriptor, so if A type is descriptor type integer and B type is also descriptor type integer, then if A byte size is bigger than b byte size. So this is the point where it becomes important, the direction of the operation, or like so this is the target, or then it is about the moves. So there are situations where the direction is important in case of a move. For example, we can move the smaller value into a bigger value, but there are situations where the direction is not important. For example, sum, right? If you have two different integers of two different sizes in a sum, then we just kind of get both of them to the common denominator, and we use that size. This is an interesting question, like what to put here. Maybe let me go back to this function. So as far as return goes, we will eventually do a move. So let's be explicit here and say same type or implicit move cast, and this is what we're gonna deal with. And then if we need something else, we decide differently, but also means that here we say target and source. So it is, at least in the function signature, it's a bit, or in argument names, it's a bit more explicit which one are we talking about. So if target and source are the same type, that is very good. If target type and the source type are integers, if target byte size is more than source byte size, then we need to actually, in that case, this shouldn't even go here, because in that case we will do it when we do the move. So what I'm thinking is that this check over here is actually sort of irrelevant, because since we're gonna do a move anyway, that move is the one who has all the knowledge and all the logic to decide if that move is okay. Right? We don't want the same logic to be implemented in two different places. So what I'm thinking is we remove this stuff from here, and that means that this thing also doesn't make any sense, and even this thing doesn't make any sense. And instead you want to put this here. Then here we assert that well, here we basically can say that else assert so basically if return type, okay, let's turn this around. Since we now have an else, it should be better to have it in the right logic. So if descriptor function returns is void, and then if to return a descriptor type is not descriptor type void, then we assert that return type is function return type implicit. So this is what we have. Now the logic here becomes if we don't have a return and we check that it's not frozen, we do this thing. Okay. And then we go to here. And that seems fine-ish. We check that it's void. If it is void, and the other one is not void, then we only allow it in implicit return types. Otherwise, we just move that value. So what happens if we do that? Because now it is the move value that will only deal with the logic about can we actually return this or not. And this is much better. So now we do have that mismatched operand size when moving. So let's do that, mismatched operand size when moving. And this is quite nice. So, yeah. Let's check what is the logic here. We get sizes. Cool. Actually, probably makes sense to do this thing here. I'm just thinking where does the check for same type happen? So this type checking thing, but let's wait on that for now. So we get the sizes. If both of them turn out to be memory operands, then we need to do this double move, so that is okay. And then we check that if their sizes do not match, then what do we do? If a operand is a register, so actually here is definitely where I want to say that target and source, it shouldn't be A and B. So let's fix that. Target size, source size. This is target, 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 and more targets. So yeah, move function is one of the most complicated ones, and part of this is because we are doing x86. Part of it is just because moving memory is the most common operation that happens in any program, so that is kind of to be expected that you end up in this situation. But yeah, still doing any changes to this is a bit painful. Okay, that's good, 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 and good. Almost done. We have target size, and we have source size. Is that all? Okay, that seems to be all. Now let's continue and read it now with better naming. So it seems to be it is actually other way around. Now that I'm looking at this, is it the other way around? No, that's fine. Yes. Okay. We are moving from source A into reg A, and then we are moving from reg A into target. Okay, that's good. If target size is not the same as source size, if target is register and source size is target size. Okay, and if target size is less than 4 or equal 4, then we do this instruction, which is move with sign extend. And actually, this is incorrect, because for exactly 4 bytes, for 32 bits, we should use a regular move instruction. Move SX is not what we want to be doing, and there is also move ZX, which is so move SX stands for signed extend, and there is move ZX, which is zero extend. So this thing about unsigned numbers is also another thing to consider when we are doing all of that. But coming back with the conversion, so if source operand type, okay. So this is the case of 32-bit to 64-bit, because, okay, that is fine. And what else do we need to allow? Okay. Let me run the tests, mismatch separation, apparent size bit moving, and let's do a bit more debugging. So encode instruction, at the end of it, we had somewhere this pretty nice thing to print this stuff. So we can print operands. So let's do that. Where were we? We were here. And I can say print operand source operand. And then I can do print operand target. And then I guess we need space between them. And then we also probably need a new line. Operand. Okay. Good. Now we'll see what we are trying to do. Yeah, it needs to be the other way around. But anyway, so we're trying to move immediate 8 into R64. It is time to bring out the Firefox and look at our move instruction and see if there is a version that would do this for us. So what we are interested in is well, basically not really, but move SX, move SXT is what we want. So there is a move SX version that does do this, but it needs to have so if target operand is registered, that is correct, right? So yeah, Target appearance register source size is less than target size, yes, and target size is less than equal 4. So this is actually a bit weird. So this condition shouldn't be here at all. Instead, what should happen is we need to say that if basically this thing that if, and it's not even that, we just need to say if source size is 4, we do a regular move. If source size is 4, then this is going to be a regular move. So which means that we don't need to do anything because it will just fall down, I guess, and do the right thing. At least we can try that. So let's do will be handled below. Otherwise, we're gonna do this thing and return. And else, we report that we didn't know what to do. So now we should end up in this branch, if I'm not mistaken, and we might need to add a new instruction encoding, which we haven't done in a while, but that is fine. Okay, so we have another problem. This happened in the spec file. Let me try to look at the source of this. So we have a reflection on structs. And then we have tagged unions. So probably it is maybe cast to tag that is causing a problem. Yeah, I guess it is this move that is causing an issue for us. Let's say, or not to move here, move is happening here. Yeah, so this stuff maybe. I think in the instruction we should have information about where it happened. So let me think about this. But there we don't yet have an instruction. We just have this stuff. So easiest will be to run a debugger and see where it's happening. Okay. Solution Explorer, properties, and spec, I guess. So F5. Yep. Where are we? We are coming from move value. So it is a recursive one that is happening here where target is not a register and the source is immediate 64. Okay. Now this is interesting. So yeah, the target is not register and the source But also not an immediate 34. I'm a bit confused. So we are inside compare. And what are we trying to compare? We are trying to compare memory indirect 64-bit thing. Okay, with an immediate 64. Okay. For that, I guess let's try to restart, but make a break here. Okay, that is not really working very well because we would have it earlier. So what I want to do instead is I want to make a thing here, temporarily remove one in compare, yeah. So F5, and now I want to get this back to compare and see where actually it fails. Okay, so this is the first one inside compare. That's fine. Let's do this again. And okay, so now we can inspect actual values that are causing issues. And they are indeed the what I was looking for. So it is memory indirect one that is coming from here. So it is the tag, and it is a value from S64 that is 1. This is also 64 bits. Why is it causing issues now? This is what I'm trying to understand. They have the same type, so that is all okay. We go inside here. Target sizes are the same. They are not both memory operands. They don't have different sizes. They will not go into this branch. They go into this branch. And this is where we are dealing with the case where 64-bit immediate fits into 32 bits. Okay. But now that should be just handled by the regular stuff, if I'm understanding all of this correctly. So I believe this thing is not necessary anymore. Let's see what happens when we try to run this. Okay, well, that is actually fine because this just means that we need to go to the instruction.c, go to movesx, and add a version that would deal with it. Oh, actually, no, not really. So movesx doesn't have a version that deals with immediates, so which means we need to put it somewhere in register or memory. Right? There is no immediate option here. That is okay. We can deal with that because the solution would be exactly the same thing as we did here, where we just transfer it through a register. Yeah. let's do that. Maybe I will extract it later on into a separate thing. But for now, this is going to be fine. So we take register A, we put in the target descriptor into there, and then we move. Actually, we need source descriptor here, not target one, otherwise it will just infinite loop and not do what we want. We create this temporary value, we move it into there, and now we want to push instruction like this. Honestly, I think I even want to not recursively call, but just do 2 pushes directly to have a bit of a tighter control over what I'm doing. So we're moving into A source operand, and then we are doing move SX from A with the right size to the right thing. Rec A. Okay, something like this. Okay, let's try that again. No matching overload found. Aha. And I guess that is another situation where we need to deal with the implicit conversions. So eventually we will probably need to extract this logic into something else, but for now let's just move on and look at this concrete case. So for that we are going to line 640, and yeah, here is our check, and this is the one that needs to be changed. So maybe the first approach was better after all, but it's fine. Same value type, or can implicitly move past, or something like this. Let's get back to here and do this stuff and say bool. Here it should be directional again, so target source, and we say if same value type of target and source, then that's good. And otherwise, if target so if target descriptor type is not the same as source descriptor type, then that's a no-go for us, at least right now. Now we say if target descriptor type is descriptor type integer, if descriptor byte size of target descriptor more than descriptor byte size of source descriptor, then we say that is okay. Or actually that is, I said okay. And if it's not, then it is not. Okay, let's see if that helps. No matching overload found. So you still are very, very unhappy. Okay. What if we try to debug you? And what is that test? Run multiple function definitions. That is inside of a function, so we need to switch that back. And let's just run this. Okay. So in which test are we? Oh, we are in one of the tests that actually deals with the parsing stuff. So that's an interesting turn. So I guess we are over here, and we are trying to call exit process, that is S32. So we are over here, I would guess. Okay, let's do 5. Yeah, we are getting to there. And now we are ready to check what is happening over here. Okay, to call function, arguments, data. Okay, that's not going to be very nice, but anyhow, I already know what is there. So one of them is would be an immediate, that is 1 byte, and another one is S32, and that is not something that we previously would accept. So we have this stuff, and we want to go inside, and we go past this thing, we go past this thing, we go inside of this, and let's actually look at our source and target. So descriptor here is integer and byte size 4. Okay, and this one is integer of byte size 1. So yeah, so the problem here is actually the order. And let's source. So actual, yeah, sectional is source arg, and this is the target arg. It should be just other way around. It's always awkward when there is directionality, but the operands are the same thing. So let's try to run test again. That is good. We are getting further, and we get to line 575, which is call function overload. And yeah, so here it is basically the same deal. I'm not even sure we need that check there, but let's keep it for now. Where we say, actually, no, we definitely don't need this check here. Let's just do it this way. But we again say source arg and target arg. We need to add type checking to move value anyway, and there is a comment about that there, so there is no point in doing it here. And that is it for this stuff. It's not a perfect solution by any means, but it is much, much better than what we had before. So that is very, very good. I think that would be it for today. That was quite a bit of a journey, and next time we can go back to some of the parsing stuff and improve that there. So thank you very much for watching, and hopefully see you next time.